1.7 literal equations. This is our last section of chapter 1. So I'm looking at testing probably a week from today on Tuesday. Okay? We'll spend 2 days on 1.7, spend a few days reviewing, take our test on Tuesday. Okay? So chapter 1 test will probably be Tuesday of next week. So, 1.7 literal equations. An equation that has two or more variables is called a literal equation. So we're going to be solving literal equations today. It's going to have more than one variable in it. To rewrite a literal equation, solve for one variable in terms of the other variables. So it'll give us an equation, and it'll say, solve for this variable. And it'll tell you the variable it wants you to solve for. Equation that has two or more variables is called a literal equation. To rewrite a literal equation, solve for one variable in terms of the other variable or variables. Any questions about that? So we're still using inverse operations to move things from one side of the equation to the other. Whatever we do to one side, we still have to do to the other. There's just more than one variable involved now. Okay? Any questions on that? Can I move on to our first example? Or do I need to give you a second to keep writing? Okay, I'll give you a second. Okay. Example 1. Solve the literal equation 3y plus 4x equals 9 for y. Solving the equation for y. Solve the literal equation 3y plus 4x equals 9 for y. So our goal is to get the variable y by itself. Trying to solve this equation for y. So I need to get the 4x away from it. I need to get the 3 away from it for it to be completely by itself. Correct? So any ideas what my first step would be here in this case? Any ideas? Anyone want to take a shot at it, even if we're wrong? It's okay. I can sit here all day. Like I said, even if you want to take a shot at it, if you're wrong, it's okay. I appreciate you participating. Any ideas what to do first to start getting y by itself? Hey, go ahead and take a shot at it for me. What do you think we need to do first here? It's okay if you're wrong.
3y minus 9.
Say it again.
3y minus 9.
So subtract 3y from both sides? Not quite. It's a good thought. But we want to get y by itself, so we want to move stuff away from y, not y itself. Does that make sense? So instead of subtracting 3y from both sides, what might we do? Go for it. Go for it. Subtract what? I heard you say subtract. Yeah, we'll subtract 4x from both sides here. Getting it away from the same side of the equation as y. Whatever I do to one side of the equation, got to do to the other. Everyone okay with that? So on the left-hand side, I have 3y left over. Now on the right-hand side, I have 9 minus 4x. Some of you might say, oh, that's just 5x. Are those two things like terms, though? They're not like terms. One has an x, one's a constant. So can I combine those? No. I can't combine them. So I'm just going to write it as 9 minus 4x. Does that make sense? If I was able to combine them, I would. Since I can't, I'm just going to write it out like it is. 9 minus 4x. Any questions on that? Okay, y is still not by itself. So what would be my next step to get y by itself? Yeah, y is being multiplied by 3. So I've got to divide by 3. Now, on the right-hand side, when I divide that side of the equation by 3, every single term has to get divided by 3. Okay? So the 9 has to get divided by 3, and the negative 4x also has to get divided by 3. That's how we divide one side of the equation by a number. Every term has to get divided by that number. 9 divided by 3 gives me 3. Will 3 go into 4 evenly? No. Is 4 over 3 in simplest form? Yep. So I'm just going to leave it as negative 4/3 x. Y is now by itself. There's my new equation. We okay with that? Any questions, comments, concerns, or confusion that I can clear up? We'll solve for y a lot when we get to graphing, when we get to these things called systems of equations. We'll do this a lot. So that's why we're doing it in chapter 1, so we're prepared for it in our future chapters. Questions on example 1? Can I move on? 3 more examples here. Solve the literal equation for y. So on all of these, we want to get y by itself. 3y minus x equals 9. 3y minus x equals 9. Any ideas for my first step here? Very similar to what we did on the previous example.
Add x or 1? Or
Add x to both sides, right? So I want to get that other variable away from y. It's being subtracted from 3y, so I need to add x to cancel it out on that side of the equation. Whatever I do to one side, I got to do to the other. Are 9 and x like terms? No. So I'm just going to write it as 9 plus x. We good with that? Next step to get y by itself. Divide by 3 on both sides. Every term gets divided by 3. Anytime I multiply or divide both sides by anything, every term on both sides has to get multiplied or divided by that number. Okay? 9 divided by 3. 3. That's like a 1 in front of the x. So that's just 1x over 3, which would be 1/3 x. Y is now by itself. There's my equation. Y equals 3 plus 1/3 x. Questions on 1? Number 2. 2x minus 2y equals 5. We're still solving the literal equation for y. 2x minus 2y equals 5. Any ideas where our first step is here? 2x minus 2y equals 5. Two x minus 2y equals 5.
Would you add
Say it again.
would you add 2y?
Now remember, we're wanting to get stuff away from the y.
Oh,
So I want to move the y itself, right?
so would you subtract 2y?
Very good. It's a positive 2x over here with the negative 2y. So in order to cancel it out, I'm going to subtract 2x. On the left, that minus sign does make my 2y negative. So I get negative 2y equals, can I combine 5 minus 2x? No, they're not like terms, so I'm going to write it as 5 minus 2x. Just rewrite it. Next step, getting y by itself. Divide by negative 2 on both sides. Every single term gets divided by negative 2. Will negative 2 go into 5 evenly? No. Is 5 over negative 2 in simplest form? Are they both divisible by the same thing besides 1? No, so it is in simplest form. I'm going to leave it as negative 5 halves. Negative 2 divided by negative 2 gives me what? Not negative 1. Positive 1x or just positive x. If you want to write the 1 in front of your x, go for it. If you don't write it, it's just understood to be there. Questions on 2? Okay, last one on this slide. 20 equals 8x plus 4y. 20 equals 8x plus 4y.
Subtract 8x.
Yep. First step here would be to subtract 8x from both sides. Can I combine 20 minus 8x?
No.
Nope. So it becomes 20 minus 8x equals, I've got 4y by itself over here on the right. And last step to get y by itself.
Divide by 4.
Divide everything by 4. 20 divided by 4? 5. Negative 8 divided by 4. What? Negative 8x divided by 4?
Negative 2.
Negative 2x. And then I've got y by itself. There's my equation. How are we feeling about this after 4 examples? Great? Good. Good. Like I said, we'll do this a lot, especially when we're graphing equations of lines, and when we get to systems of equations. So, can I move on? Next example. Solve the literal equation. Y equals 3x plus 5xz for x. I've got 3 variables in there now. Uh-oh. Y equals 3x plus 5xz for x. Solving my equation for x now. Let me hear some ideas here. Any ideas on what to do first here? Trying to get x by itself.
Eileen said she knows.
What's up? You want to try it out?
No.
For volunteering other people for it? We want to take a shot at it?
Would you combine 3x and 5x?
It's a good thought, but are these like terms? Do they have the same variables that have the same exponents? No. This one has a z, this one does not. If this one had a z, I'd be able to combine them.
Yeah.
But it does not, so I'm not able to combine them. It's a good thought, though. You can go for it. This one's a little different, so bear with me. I'm gonna do what we call factoring out a greatest common factor. Yeah, have you guys heard that phrase, greatest common factor? No, you haven't? What's the greatest common factor of, let's say, 6 and 12?
3.
6. It's the biggest number that goes into both of them. Does that make sense? But we're also going to deal with variables here. We're just going to look at the variables. What variables do these two things have in common? X. So what I'm going to do is what we call factoring out an X. We're going to think reverse distributive property here when we're doing this. Okay? If I were to distribute this X into this parentheses, I would want to get back to my original equation. So, X times what would give me 3X? 3. So it's just going to be 3 right there in that first part of the parentheses. And then X times what would give me 5XZ? 5Z. Does everyone see that? Now, if I distribute that X back through, I would get back to my original problem. Does that make sense? Now, I just have one X out here by itself. It's not split between two different terms, is it? So, now what I'm able to do, since I'm solving for X, what's the operation going on between X and the set of parentheses? Multiplication. What's the inverse of multiplication? Division. If I divide this side by 3 plus 5z, those will cancel out with each other. Does everyone see that?
Yeah.
Whatever I do to one side, whatever I do to one side of the equation, got to do to the other. There's my answer. I can't do anything else with that, so there's my answer. We okay with that? I know it's a little confusing. It can be a little confusing. But I'm pretty sure, pretty sure, most of the examples, or most of your problems in your assignment for today that involve factoring out a variable are about the same amount of steps as this one. Okay? I've got some more examples to give us more practice with these. I'm going to go ahead and move on to those. Number 4. Y equals 5x minus 4x. Solve the literal equation for x. Any ideas on number 4? On this one, we do have like terms. My two terms, 5x and negative 4x, have the same variable with the same exponents, correct? So I am able to combine here on 4. What's 5x minus 4x? X. Which variable am I solving for? X. Is x by itself?
Yes.
There's your answer. We okay with that? Questions on 4? If you can combine like terms, combine like terms. Okay? Number 5. 2x plus kx equals m. 2x plus kx equals m. Do I have like terms here? Huh? No. That second term has another variable with it of k. Does 2x have k in it? No. So we're going to have to do something similar to 2 examples ago. So, which variable or variables do these 2 terms have in common? X, I'm going to factor out that x. Still thinking reverse distributive property here. If I were to redistribute, x times what would give me 2x? 2. X times what would give me kx? So I get 2 plus k in parentheses equals m over here. Am I moving too fast for anybody? Slow down if I need to. Now, how would I get x by itself? Divide by the thing that's being multiplied by x. So divide both sides by 2 plus k. So I get x equals m over 2 plus k. Can't do anything else, so there's my answer. Questions on example 5? Can I erase 4 and 5 to give myself a little more room for 6? Number 6. 3 plus 5x minus kx equals y. Still solving for x. Do we have any like terms we can combine? No. What do I need to do? This one's a tad different from those other 2 that we saw. There's one step I got to do before I factor out an x. Say what? Yeah, I'm going to subtract 3 from both sides because does 3 have an x with it? No, I'm just going to get all the terms that have an x on the same side of the equation, everything else on the other side. So I'm going to subtract 3 from both sides. Can I combine y minus 3? Nope, so I just rewrite it as y minus 3. Now what would I do? Yep. Both these terms share an x, so I'm going to factor an x out. X times what would give me 5x? 5. X times what would give me negative kx? Negative k. So I get x times 5 minus k equals y minus 3. Almost there. How would I get x by itself now? Divide by 5 minus k. There's my answer. Questions on these types of examples? We good? That's all I got for you. Can I move on to the assignment? Or are we still writing? Page 50. Numbers 4 through 26 evens. I think it's 12 problems. All about solving these literal equations. Make sure you get this written down. Make sure you get the correct heading on your paper, name, date, period, assignment in the upper right-hand corner. If you don't finish in class today, it'll be due Thursday the 7th on Canvas. Are there any questions about any of the notes before I end the recording?